This conference will now be recorded.
So very good evening, students. Today we'll be actually formally concluding this web chapter by discussing few numerical problems on Doppler effect. So before I go to the problem directly, I'll write the formula for your sake. Like there are various situations that, if you remember, when the observer is stationary, source is moving towards the observer, and when the source is stationary but observer is moving towards and away from the source. So in such cases, what will be the frequency heard by the observer? Okay, so let me write down at the end, maybe somewhere here, write down the formula first, just to recap. So this is the case. Suppose the source moves towards the stationary wave. Source, this is case 1. Okay, first source moves towards the stationary observer. Stationary observer. Okay, so in that case, the frequency observed by the observer will be nu prime is equal to v by v minus vs into nu, where this nu prime is the modified frequency which the observer will hear. V is the velocity of sound in the air or in the medium of sound in the medium. In this case, we may take air. Okay, and Vs is the velocity of the velocity of source. Okay, source of sound. So this is the case. If suppose the source is moving away, so it is moving towards the observer, stationary observer. If the source moves away from the stationary observer, so in that case what will happen? Just you have to replace Vs by minus Vs. So this will be the frequency will be nu prime v by v plus vs, because we have replaced vs has been replaced by minus vs into nu. Okay, so this is when the source is moving. Let us go to another situation. The source, third case, when the observer moves towards the observer, sorry, source. Observer is moving towards the source. Then what will be the frequency heard by the observer? That will be V plus VO divided by V into nu, the frequency, original frequency of the sound emitted by or left by the source. So V, you know, the velocity of sound, VO is the velocity of or speed of. Here I am writing velocity, thinking that this is in a straight line motion. Velocity of the observer. Okay, velocity of observer. Now, how will this change if the observer, when the observer moves away from the source? So this will be nu prime is equal to, so here VO will be replaced by V minus VO divided by VO into nu. Okay, so this is the case. Now we'll recap the last situation where both the source and sound moves, source of sound and observer moves. So fifth case, when when both the source and sound, source of sound, when both the source and observer move towards each other, towards each other, towards each other. So in that case, what will be the modified frequency? So the modified frequency which will be heard by the observer is this is O, this is not naught, this is not 0, this is O, observer. So V plus VO divided by V minus Vs into nu. So you know this V and VO and Vs, these are having usual meaning. This is the velocity of the source of the sound, this is the velocity of the observer, and this is the velocity of the sound in the air. If nothing is mentioned, medium is not mentioned, then it is air. Okay, so some cases velocity of sound may not be mentioned, so in that case you have to take velocity of sound in air 340 meter per second, or this is in air 340 meter per second, or maybe ideally you take 330 meter per second in air at room temperature. Okay, so this case, how would this change if uh, if the source moves towards the observer and observer moves away. If source moves towards observer but the observer moves away from the source, away from the source. In that case, okay, so in that case, this VO will be replaced by minus VO divided by V minus Vs as it is. This is new. Okay, we have another two more cases. Now look, this is sixth one. Let me tell you seventh one. Seventh case is if the medium moves with velocity Vm in the direction of propagation of sound. See here, the case is like this. Source moves towards source, both source and sound, both source of sound and the observer, both source and observer move towards each other and medium moves medium also moves in the direction direction of in the direction of velocity of sound, velocity of sound with velocity Vm, velocity Vm. So the situation is something like this. Source is moving towards this. Observer is moving like this way. This has velocity VO, this has velocity Vs. And now the medium also started moving with velocity Vm along the in the direction of velocity of sound. So in that case, how the frequency or what is the frequency heard by the observer? This will be V plus Vm if the sound is moving in the direction of the medium itself, minus VO divided by V plus Vm minus Vs. Okay, so this is the okay, there should be a positive sign over here. Okay, if the medium is moving in the opposite direction, if medium moves in the in a direction opposite to the direction direction of velocity of sound, then frequency will be B minus Vm. Here, this can be plus, okay, and this also can be plus or minus. Minus plus. I'm writing plus. B plus Vm. This is plus or minus Vs. So these are the formulas. Okay. Now you might be bored with the. Anyway, we are going to use this formula and then we'll be able to understand how to apply and which one to apply. Now let us read the problems one by one and try to solve them. Okay. The first problem is saying that an observer standing on a railway crossing receives frequency 2.2 kilohertz and 1.8 kilohertz when the train approaches and recedes. Approaches means the source moves towards the observer, stationary observer, so the source, and recedes means the train is just recedes means crossing the person and moving away. So this is the source moving away. This is moving towards the observer. Now this is moving away from the observer. Recedes. Recedes. Okay. All right. So find the velocity of train. The speed of sound in the air is given as 300 meter per second. As I said, speed of sound in the air will be 300, 340, 350, etc. So you have to find out the velocity of the train. So velocity of the train, here what is the situation? The situation is that the train is coming towards the stationary observer. This is yes, this observer, and going away from the observer. This is the situation. So we have seen already the frequency, new frequency will be, so suppose when it is approaching towards the observer, then new frequency will be v, that is the velocity of sound, divided by v minus vs when it is approaching. Okay. All right. With this, so here what is given is this one, new prime. Okay, so there are two cases you can see. One case is when approaching, that time the frequency heard by the observer is 2.2. So we'll write from here that 2.2 is equal to v is the velocity of sound in the air, so 300 divided by 300 minus vs. Vs is the speed of the source, that means speed of the or velocity of the train itself. So let us give this equation as 1, equation number 1. Now see, when it is receding, this is approaching, approach and recedes. So when it is receding, then v divided by b plus vs into nu. So this is the case. Here nu will be there obviously. So nu is not given anyway. So from here we can write 300 divided by 300 plus of vs. Obviously when the source is moving away from the observer, then the sound frequency of the sound will be decreasing. That's why this denominator is larger than this denominator. Okay, so we have got the equations. We have got two equations, so we'll just remove this part so that we can solve this to find out vs. All right, look, we have got these two equations, so I can just take ratio. If I take ratio 2.2 divided by 1.1. This is 300 divided by 300 minus Bs. Nu will go off from both sides, divided by 300. Okay, so this will go off. What will be there? This is, suppose this point you remove, so 11 by 9. So 11 by 9 is equal to 300 plus Bs divided by 300 minus Bs. Okay, so now I'll remove these equations also. If we do little bit of simplifications, see 11 300 minus Bs, this is 9 300 plus Bs. Okay, we have to find out the Vs. So 11 Vs, let me take it to that side. So 9 plus 11, this is Bs. So here I'll just bring it here. So Vs was minus over here, right? Okay, so here there will be minus sign. Better to take it that side itself. Let me take this side, and then it will be 3300 minus 2700. Okay, so Bs will be, this is obviously 6, and divided by 33. Okay, just a minute. So here it is 2. 2 means 300. 300. Okay, let me just check once. Oh, I see. This is actually, but anyway, kilohertz. All right. We have done a little mistake somewhere. Oh, this is actually a plus, I hope. This is okay. So this will be plus. I'm sorry. This will be plus. So here it will be 20. So therefore, you will get 30 meter per second. Okay. So 30 meter per second. So this option B will be the correct answer for this case. Okay. So here speed of sound was given. The speed of the source had to be calculated. Okay, so we have used the formula and then had done little bit of simplifications, and then we have solved it. Now we'll go to the next question. So what is this next question saying? The next question is saying a moving at police car moving at 22 meter per second chases a motorcycle. A policeman sounds his horn at 176 hertz, while both of them moving towards a stationary siren of frequency 165 hertz. Calculate the speed of the motorcycle if it is given that he does not observe any beats. He does not observe any beats. So here actually you have to just understand this problem first. So this is a police car. So PC police car. It is moving with certain velocity. That is, suppose this is source one actually, source one, because he is also the policeman also is sounding a horn. So that is 20 meter per second. Then motorcyclist also moving in the same direction. We don't know the speed. Suppose this is V observer. Okay, so in this case, the frequency of the sound wave was like this. Okay, now another situation, suppose both of them are moving towards a stationary siren. Okay, stationary siren, which is actually emitting a sound of frequency 165 hertz. 165 hertz, and this source too has velocity 0, stationary. You have to find out the speed of motorcycle if the motorcyclist does not hear any beat. Okay, let me tell you one thing here. You have to actually find out the frequency, apparent frequency heard by the observer in both cases. Suppose the apparent frequency in this case is nu1 and in this case is nu2. So the condition for not observing bits are actually nu1 is equal to nu2. What is bit? Number of bit will be nu2 minus nu1, kind of that. So they should have at least difference within I think 10 or 13, some difference of 10 or 13 it should be. I hope it is 10. Nu1 minus nu2, they should have a difference of at least 10. If both are same, then there is not going to happen. Bits not going to happen. Anyway, so our primary problem is here is to find out the frequency of the sound, apparent frequency of the sound observed by the motorcyclist when the horn of the police car was blown. So in that case, see, both of them are moving in the same direction. Both of them are moving. So in this case, both source and observer moves. So then in that case, the frequency will be nu prime is equal. So I am writing it as nu1. Nu1 will be equal to V. Here actually should be V O B minus Vs. Actually, this is the formula with the nu. This is the formula when both of them moves towards each other. But when they move, see, I think you have to just use this. Here it will be a minus sign. Okay, because the relative velocity will be in that case less when they are moving in the same direction. Okay, all right. So in this case, look, the speed of the sound is not given. We will be taking this as 330 meter per second. V will be taking as 330 meter per second. That is the sound in air. Speed of sound in air. Okay, so if we just put that, so this is 330 minus VO observer, that we have to find out, and this is again 330, sorry, 330 minus VS is the source. Here it is the police car, this into the frequency of this. So the apparent frequency which is heard by the observer for the police horn is this much. Okay, I'll just keep this as it is, and let me find out the new 2 also. I'll just remove this part. So what is new 2? New 2 is actually they are both moving source and they are moving towards a stationary observer. Towards a stationary observer, in that case, you know what will happen, because it is moving towards the source. So V plus V observer divided by V. Okay, because the source is not moving, Vs is 0. In the second case, the frequency new. This is a new 2 anyway. Now if you put the values 330 plus V0 observer's velocity, that we don't know, we have to find it out. So this is again, I'm sorry, this is only V, and along with that there will be 165. Okay, so this is new 2. Now I'll just go for erasing this portion. So for no bits to happen, for no bits, new 1 will be equal to new 2. So we'll directly equate them. So these are equal. Now this is VO. If we solve this for VO, then you will be easily finding out that this is 20 meter per second, same as the velocity of the policeman. So if you solve this problem, the numerical part, then you should be getting that the velocity of the observer or the motorcycle will be 22 meter per second. Now we have another third problem. Okay, so I hope this I'll write. Okay, new 1. Okay, anyway, this is already done. Let us go to the third one. In this case, the problem is a train moves towards a stationary observer. Train moves. This is observer. So stationary observer VO is 0. VS is there. That is 334 meter per second. 34 meter per second. Okay. With this velocity, a train is moving with blowing the whistle of frequency F1. The frequency of the sound wave is F1. Now, if the train's velocity is made this much, just half of the original or the previous velocity, then the frequency registered by the observer is f2. In this case, observer is saying of f2. You have to find out the ratio of f1 to f2 when 340 meter per second is the speed of the sound in the air. This is very simple. If you see, when the velocity was greater towards the observer, let me write the source is moving towards the observer. That means nu prime will be, or here it is written as f1 first. So f1 will be v divided by v minus vs into original frequency. That is the suppose nu. So this is the vs when, so f1 when vs is actually 34 meter per second, and v in place of v will be replacing 340 meter per second. This is 340 meter per second. This is 340 meter per second. And f2 when the speed is decreased. So 340 anyway it is not going to decrease. 340 minus 17. Okay. Now we have to take ratio and solve this. We have to find out the ratio. That is the question. f1 by f2. So f1 by f2 will be 340 divided by, so 340 minus 34 will give 640. So 306. This is 306 and it is 32 divided by 340. Okay. 17. 340 by 70. Let me see. Okay. So this we can see how it is. We may just do a little bit of calculation and find out what may be the ratio. 340 meter anyway. Oh, I'm sorry. This is okay. Anyway, source is moving towards the observer. That is true. So here actually the answer will be 18. Let us just do one thing. 330. Actually, this should be 19 by 18. So we have to find out from this ratio. All right, so here the answer will be the option D. So this is how one has to solve problem related to this Doppler effect. As I said, one should remember all these formulas which I had already written in the beginning. And we have not solved any problem related to this, but we in the later classes when we discuss various competitive exam question papers, we'll be doing further uh, on this. So I'll just stop it here for today. We'll meet again uh, with interesting topics and numerical problem, etc. So bye for today.